Hi, I'm Betsy. I'm a software engineer at Console, where, to put a long story short, we automate internet infrastructure. So, of course, we have to keep track of a lot of routers, switches, ports, pseudo-wires, IP pools, lots of other stuff, statistics. So I have to work with databases a lot as I write code, as do most people in most software projects. My background is in artificial intelligence and algorithms, as well as linguistics and history. I'm someone to whom abstract things come easily and practical things go in one ear and out the other. So this sort of stuff, I've always been like, hey, I know how to use databases, I know how to code. How do I put things together? And it seems very simple, but that was a struggle for me for some time. So that's what I'm here to talk about today. This is just supposed to be a kind of super basic, some examples, introduction to concepts, things to look out for, kind of guided. Here's a thought process that you can use. A lot of people in this room probably know more about this stuff than I do, but if at least one thing I say is useful to at least one person in this room, and you don't all boo me out of here, then I'll consider the talk a success. Besides, it's day 3 before lunch. We've had a morning of excellent talks. I don't think any of us need much more mental challenge right now. Okay, so we're going to do a thing, and we're going to need a database. What database are we going to use? There are so many different database systems out there, like so many. Everybody has their favorites. Everybody's favorite is better than all the others. Everybody has a different favorite. It's just like programming languages. I'm not going to tell you which one to use, but there are different databases for different purposes. So there's your usual relational type databases that have been around a long time, are very well established. A lot of people find them really boring, but they are very practical. There's NoSQL databases, which are really popular. I don't really get the point of them. Maybe somebody can tell me in question time, if there's no other questions, why anyone would use one. There's databases for more specific things, like time series databases, which are good for chronological data, things that might be coming in fast and need to get processed fast. There's graph databases, which are really good for graph inference, and a whole bunch more. So I'm going to ask, does anyone here have a favorite database? What is it? Yell it out, not at the same time, please. Okay, heaps of people said Postgres. You're all going to be very happy in a minute. Somebody said SQL Server. Is there anybody else who's got anything different? MySQL. SQLite. Yeah, people like that? I'm not sure if I should repeat that one for the camera. So a lot of people like Postgres. A lot of people liked, was it SQLite that a lot of people liked? There were a few others that people mentioned. For the purposes of this talk, we're going to use Postgres because I'm familiar with it. It's been around a long time. It's well established. There's a lot of cool tools. It's easy, it's robust, and it's very fast. If you're interested, I'm going to be running Postgres in a Docker container today because that's easy. You should do that if you haven't done that before. Okay, what language are we going to use? I'm not going to open this one up for debate. We've had enough debate about that already this weekend. But I'm not here to tell you which language to use. Of course, you probably don't have much choice in a lot of software projects unless you're starting it from scratch all by yourself. There's going to be a lot of factors that influence that. For the purposes of this, I'm using Python because it's what I know best and because it's easy to read. But the concepts that I talk about are the same across all languages, I hope, all widely used languages. Okay, we've got 2 things. How do we put them together? It sounds obvious, but as well as having your database and having the environment that you're going to write your code in, and knowing what the environment your code is going to run in, because that's very important, you need to know how to get between the two. Sometimes it's easy. Sometimes you're running it on the same computer, like I am here. Sometimes your database is off in some cloud somewhere. You may not even know which one or where. Sometimes your code is off in some cloud somewhere. Sometimes they're in different clouds. You need to make sure that all of the different places can talk to each other and that you know how to get from one to another, which should always be easy, but then occasionally it isn't. All right, so I am going to give my database connection details here. Also, a note on security, which I'm probably not going to mention again. Think about security, especially when you're thinking about how information gets from one bit to another. Does your information need to be secure? And also, are you putting your password in your code in plain text that you're going to upload to GitHub? Just think about that. Okay. I'm tangled. We need to write code that interacts with the database. We're not going to write it from scratch because we're not insane. We are going to find a library that does that for us. There's so many different libraries, so many different languages. Of course, I'm going to be giving some Python examples here. But of course, every language has a plethora of database libraries. They vary. There's different kinds of levels of abstraction. There's your low level. This interacts directly with the database. So in Python, they're called database APIs. I like to think of them as database drivers. Some people may not like that term. They actually communicate with the database. They're very basic to use. You have to deal with a lot of the low-level things yourself. A lot of more abstracted libraries are built on top of them. And they may abstract away stuff like session management. They may try and provide you a different querying interface other than writing SQL yourself. There may be these things called object relational models that take data in your relational database and put it into a form that you can treat as an object in your code. What you need is going to depend on how you're going to be using your data. So let's give some examples. So first example I'm going to give is using a very low-level database API for Postgres in Python called CyclePG2. There are a lot of other database APIs for Postgres in Python. CyclePG2 is the widest used. So you have to give it connection details, and you create a connection, and it gives you something called a cursor. You'll see this in a lot of database stuff. You get a cursor is how you interact with the database. It's like if you're writing in an SQL command line. This is where you're up to now. Sometimes you'll have to iterate through rows in the table using that cursor. Sometimes the library will take a step back, and you won't have to go through every row yourself using the cursor. It'll get them all at once. Depends on the library. A few important things to note here. See the bit where it says closed is 0? You need keep that in mind. You need to know if your connection is open or not, because if it's closed, then you can't get anything. But if it's open, then you are keeping that resource set aside for data which you may not need. All right, so with something like this, I'm literally just executing SQL. So I'm not going to tell you how SQL works. But there's queries, and then I have to commit these queries. So most of these things work in a transactional system, if you're not familiar with that. So your database connection is often split up into transactions. If it's not, then question your choices. Transactions are good because if you make a mistake halfway through your code, and it goes, oh, can't do this, doesn't execute the rest of the things, none of the stuff that happened before the point where it died gets pushed to the database and actually happens. So you don't have to go, but where in my code did it break? What happened before then? What changes were made to the database? How do I deal with that? You know, okay, nothing in this block happened, and you know that for sure, and you can deal with that in a logical way. just to prove to you that it works. You can see the table I made actually exists. And there's a row in it. Yay. Okay, so then how do you get stuff back out? That's a bit more complex than just sending SQL there and trusting that it works. It's not really that much more complex even in this. You execute a thing and make sure that you can get stuff back. A lot of these libraries will have a lot of different methods for executing things. So you notice instead of, or different methods for getting things back out. So there'll be some things that fetch one result. There's some things that fetch all results. There's some things where you have, like I said before, you have the cursor and you have to iterate over everything yourself. So just be aware of what the library you're using does. And now that I have put some data in and I've gotten it back out, I'm going to close that connection. Because, see, it now says it's closed. For example, when I was testing a lot of the example code in this talk, I ran out of connections on my database because I broke things that often that my connections didn't get closed. It's just good practice, like closing files after you've done reading and writing with them. Some libraries, the more higher level ones, will handle that for you. Some libraries won't handle that for you. You need to know what the libraries you're using are doing with those connections when you're done. Do they close them always? Do they close them in some circumstances? Maybe it doesn't close it if there's been an exception, but it does close it if there's no exception and it got to the end. Some things to look out for. All right, here's an example of a much more high-level library. So Sql Alchemy does everything to do with databases. You don't just have to use it with Postgres. It uses a whole bunch of different database APIs on top of different databases. So this is actually using PsychoPG2 under the hood. Right now, it could be using other things if I was using a different database. I'm just importing all these things here because the next slide is big. All right, this is an example of an object relational model. You're not always going to need to use one of these, even if you're doing a relational database. But if the stuff that you're storing in your database is something that would be useful for you to interact with in an object-like fashion, object relational model is the easiest way to do it, so long as you've got a good library that does it. It handles a lot of things. So you can see here, I'm defining my tables as classes. I've got my columns as class attributes. I can define whatever methods I want. They may or may not have anything to do with the database. And they're all inheriting from this declarative base thing, and that provides the link to all of the under-the-hood stuff. So all of the metadata, all of the things that allow Sql Alchemy to transform this class definition into, say, a create table statement, and so on. So it handles all of the complex things. And so long as what you're doing, of course, fits in with the library's way of doing, that means I don't have to do any of those complex things, and it's easy. So make that. It does require a little bit more code to actually create the things than you saw the example in PsychoPG2 did, because there's more going on. But then later, when it comes to actually using all of the things, it's much simpler. So it's a case of putting in a lot of work at the start to make future you much happier when you're coding, or other people you're working with on the same project, so our future contributors much happier. So we have to create an engine in much the same way that we had to get the connection for PsychoPG2. And this magic line here constructs all the create table statements from all of my class definitions, writes it, commits it, everything. And then I'm using this thing that comes with Sql Alchemy called a session maker that handles sessions in a slightly smarter way to get a database session to do a little query to make sure that it worked. Of course, there's nothing in that table, so we get an empty list, but it tells you that it works. One thing that I found very useful is to put things like this liberally throughout any kind of prototyping stuff I'm doing or testing that I'm doing with databases, especially if you're working with multiple databases. Say you've got different databases for different purposes, or you've got your own test one, you've got maybe a test one for your broader team, and a production database. I get really paranoid about what database am I actually doing things to, and I find it very reassuring to have things like this that tell me constantly, you're working on this database, you're working on this database. Really helpful. In fact, one of my later examples uses a library that doesn't have anything that lets you do that, and it made me really annoyed, and I probably won't use that library unless it gets a way to tell you, okay, this session is connected to this database at this address, because that's really scary, not knowing where your database is. All right, we're just going to populate that table. So the only interesting thing to note here is that because I'm using an object relational model, I can create all of the rows in the table just like I'm instantiating a class. I don't have to write insert statements, nothing. And look, it worked. And because I want to interact with these things in an object way, you can see that it's constructed relationships between the objects. So the fact that choose-a-chew is a lightning monster the word lightning is in a different table from the monster table that has choose-a-chew in it. So it can just follow those relationships through, which is a good thing and a bad thing. Depends on how you're going to use it. It makes it really easy to write the code. It also means that it's preloading all of that other information when it fetches that object, which you can control in this particular in Sql Alchemy. You can control whether it preloads things or not, but if you can't control it in another library, that could mean that you are loading a lot of information that you just don't need. Another thing to be aware of. Here's a slightly more complex query. So here, you'll notice I'm not doing any SQL. I use this query interface that it has, and it creates the SQL. You can see below there. This is another thing that I've noticed different libraries do very differently. Some things have a kind of query API that is very similar in structure to SQL, and as somebody who's very comfortable with SQL, I like that because it means I know what's going to happen. Some things have a very non-SQL query structure, very weird and wonderful query languages, which I don't like because I don't know how they work. You may like them if you don't like SQL. It's another thing to look out for. And like a good person, I'm closing my session. Okay, so there's a lot of libraries out there and so on. You can pick whichever one suits the way you want to use your information that's in your database. But don't forget that you can write nice things too. Databases are things that you're going to be using a lot throughout your code most likely. So make sure you put in the thought to how am I going to be interacting with this information, and what sort of things can I write to make it easier for future me. Don't people always say that the best programmers are lazy programmers? Be nice to future you. So here's an example. Instead of having to deal with closing my session manually at the end, I want to use a thing that will close it automatically for me. In Python, the perfect thing to do with this is to write a context manager. This is not a great one. This is a very simple one. If you're not familiar with context managers, when you initialize it, it does all the setup, and then you say with whatever. And when you call that, it calls this enter, and it sets everything up. And then when that with statement ends, it runs exit, no matter whether it reached the end of execution normally or whether there was an exception or anything else happens to stop what's happening in that with statement, exit will run. So I know that it's safe to put close in there because it'll always happen. If you're going to be smart, you would catch those exceptions and go, okay, do I need to say to abandon everything that's happened in this transaction? Is it bad and should die? Or should I commit it because everything's happy and move on? So that's an example. Instantiate it. And then that means that everywhere that I want to look at pocket monsters, all I have to do is this. No more do I have to go, oh, where's my cursor? Where's my connection? Where's my session? Do I close the session? Did I not close the session? Some libraries out there will do this kind of thing for you already. Some won't. It may be that you have the perfect library for everything else. It doesn't do something you really need. It's something that it's easy for you to add. And whether that's something that is an intrinsic part of the system you're writing because it's got logic that's unique to your software, or whether it's something that you can, as Clinton was saying this morning, give back to the upstream thing if it's an open source project. Those are things to consider. And here's just a slightly more complex example for fun. Whoops, I didn't run it. There is a slightly bigger version of the above thing at that address there, which I can give you later if you like. Okay, what happens when you break things? Because there's so many more ways to break things than what I'm going to give here, but some things to look out for. So I keep talking about sessions and cursors and transactions, and they're not things you want to know about because they're just too many details, but they are things that you've got to be aware of and keep in mind, and hopefully you'll find a nice library that will handle it all for you, but you still need to know that it's going to handle it all for you. So if we run this, oh no, a mistake in my SQL. That will happen a lot, often. And of course, it means that this doesn't run. That's fine. I can fix it and rerun it, right? Let's not do that. Let's run this. Wait, I can't run it because there was already an exception in this transaction. So the transaction is dead. There's no transaction. Everything is terrible and won't work because this transaction has an exception in it. This is a thing that happens a lot. Some things will handle that for you. All right. This is why you don't live code. That's supposed to work. It doesn't. Anyway, normally, if it's not out to get you, then rolling back the transaction will start a new transaction, and then you can continue on as usual. This is why it's important to know, does your library handle this for you? Does it automatically roll things back when an exception occurs and create a new transaction, or does it leave it for you to deal with? Okay, here's another one that you'll run into a lot, especially if you're using something more high level. So a lot of the higher level ones, especially the object relational models, each object keeps track of what database session that it's attached to, which is great. That's how it can do things like, oh, somebody's requested this attribute which maps to this other table, which maps to this other column. I can just submit a new select statement to the database and fill that all out. It does that behind the scenes. It's magic. So that's why it needs to keep track of the session for all of the magic things it does behind the scenes. But that also means that you may not be able to use the things you've gotten out of the database if that session is closed. So it's outside that with statement. The session has been closed. My monster object no longer has a session attached to it. So my library says no. Again, in this one, it's a thing that you can turn off, but if you turn it off, that means that you're going to have all of these monsters everywhere that aren't attached to sessions, which means that you can't do the same things to them as you could 5 minutes ago when they were in their session. And that is massive potential for bugs and inconsistencies, because you have this object that sometimes behaves in one way, sometimes behaves in another way. And plus, of course, there's memory issues if you're accumulating a lot of things. So it's a thing. You can keep your things around forever, but do you want to? Okay, we have 5 minutes. Okay, let's talk about asynchronous things, because everything is asynchronous, because it's 2016 and asynchronous is like the big word and has been for 10 years and isn't going away. Everything is asynchronous. Some databases don't handle it very well. Most do, because databases have been designed for concurrency for a long time. Some database libraries can handle it. Many of the libraries can't. Some aren't specifically designed for it, but still work. Some work very well, even though they weren't designed for it. Some totally die. Others seem like they're okay until suddenly everything gets mixed up and you have too many sessions and things that you thought were in one session were in a different session, and badness happens. But there are some that are specifically designed for it. So if your system needs to be asynchronous, there's a few things that you can do. Here's a quick example of a new one called AsyncPG that's been going around the internet, because apparently it's very, very fast. I'm not going to do the things with it that are very, very fast here. But I wanted to play with it. That's why it's here. So we're using, this is one that makes you write the SQL yourself, which, depending on who you are, is a good thing or a bad thing. I'm just doing something very simple that gets everything out of my tables and prints them. I've added some delay to the start, because mostly the reason that you would want to be writing things asynchronous is because you're expecting delays, whether that's because you're fetching a large amount of information from your database and you don't need to process it until it's all there, or whether it's because maybe your database is very far away and it takes a long time to get there, or maybe it's like across a mobile connection and it's unreliable or something like that. So I've added some artificial delay just to find that. And what we're going to do is call that function before, and at the same time call another function that just prints something out every second so that we know how long it's taken. This is a very fancy example. So look, it is actually asynchronous. Like everything else, whether or not asynchronous database connections is something that you need is going to depend on what you're doing. Don't make things asynchronous if they don't need to be, because then you have to follow through what is happening. It makes things much harder to read and debug. You can have interesting issues with databases or anything else where you've got something else over there that's persistent, where you're like, okay, the point of asynchronous things is I don't know what order things happen in, so have I updated that yet when I read it? Have I updated that when I update it again, when I read it from the first thing? All things to be aware of. And that's it for me. So thank you. If you've got any questions or you want to tell me all the useful things that I didn't cover, let me know.
Thank you, Betsy. We have a couple more minutes, so if we have a bit of time for questions, if anyone has any.
Behind the counter there. Is that the same question?
I was thinking that too.
This is a Jupyter notebook. Ta-da! I'm using a notebook extension called Rise, which is amazingly easy to install, and all I have to do is like say, is this a slide or a sub-slide, and then press Alt-R, and magic happens. I saw a bunch of people do this at PyCon earlier this year, and I copied them because it's brilliant. I didn't have to do any formatting. And it almost all worked, the code. Almost. Any other questions? Comments? The question is about how do you handle errors in asynchronous code. That is, there's probably a whole library full of books written on that topic. It mostly probably comes down to being aware of just remembering every time you're writing something asynchronous, the whole point of asynchronous is you don't know what order things happen in. And just keep that in mind the whole way through, and you're less likely to run into trouble. And yes, testing, have test cases, all kinds of the usual testing stuff. It'll help you find all of the problems. And writing your code to be as readable as possible, comments, stuff like that, also helps the inevitable time. You're like, what order is this happening in? I don't know. In Python, I use logging heavily for that kind of thing. If there's weird asynchronous stuff happening, turn on trace logging in all of my messages, or debug logging all of the little messages that say, this is where I am, turn up.
Down the back in the, just behind the counter again. Yeah.
The question is there a difference between DB API and DB2 API? I don't know what a DB2 API is. I'm not sure, sorry. I will Google it later.
All right, I think we give Betsy a round of applause.